Hi, in this video I'm going to be showing you why the geometric series a plus ar plus ar squared plus ar to the power of 3, etc., etc. is equal to a over 1 minus r when r is between 0 and 1. I'm going to show you this using this diagram over here to the left. The first step for this visual proof is to name this line over here y is equal to x. Okay, and this angle over here, theta, is going to be 45 degrees. Next, we're going to name this point over here 0a. Okay, and this length from this point to over here is going to be a. What we're also going to do is call this length over here, from this point to this point over here, a times r. Okay, now we have to name this line over here, and lines are of the form y is equal to mx plus c. M is the slope of a line, and c is the y-intercept. Okay, that's the y-intercept. So if this line is going through 0a over here, then the y-intercept, okay, is going to be a in this case. Now, what about the slope? Well, here we have the rise, which is ar, and over here we have the run. The slope is rise over run. So for this particular slope over here, we are going to get ar over a. Okay, and we can cancel out the a's over here like this, so that slope is simply r. So let's come up with an equation for this line over here. We know that the slope is r, so what we're going to get is y is r times x, and the y-intercept is going to be a. Okay, it means that this line over here can be described by y is rx plus a. Now, as you can see, the line y is equal to x and the line y is equal to rx plus a, they intersect right up here. Let's find what these coordinates are, because we'll know what this geometric series over here converges to if we do that. Okay, so we're looking for that intersection. We have the line y is equal to x and y is equal to rx plus a. We are going to make the equation x is equal to rx plus a to find that intersection. From here, we try to isolate x. We subtract rx from both sides of the equation, so we get x minus rx is equal to a. We then factorize, so we get x multiplied by 1 minus r is equal to a. And then what we do is we divide both sides of this equation by 1 minus r. So at that intersection, x is going to be equal to a over 1 minus r. Okay, now what is y at that intersection? Well, we just plug this value over here back into y is equal to x. It means the intersection is going to be a over 1 minus r, a over 1 minus r. Let's write this up here. So this intersection over here is a over 1 minus r, a over 1 minus r. Now we're really close to ending this proof. we are just going to add some extras to this graph over here to show why this geometric series converges to a over 1 minus r. Now remember that r is between 0 and 1, so it's going to be fractional, and this AR over here is smaller than the length A. Okay, now because this line y is equal to x is at 45 degrees, this length over here is also going to be A times r. Okay, now if the slope of this line is equal to r, this length over here has to be AR squared, because AR squared over AR is simply r. Once again, because this angle over here is 45 degrees, this length over here is going to be AR squared. So you can imagine a square being split in half over here. Okay, that is why these two distances are the same. Once again, because the slope is r, this smaller length over here has to be AR to the power of 3. And if that is AR to the power of 3, then this length over here has to be AR to the power of 3, because once again, this angle here is 45 degrees. And we could go on and on. All in all, if we sum up all these distances horizontally, that is a plus AR squared plus AR to the power of 3, etc., etc., or vertically, because it's the same thing, we get a plus AR squared plus AR to the power of 3, etc., etc., we are going to get the convergence a over 1 minus r. Okay, so that's our visual proof complete. We've shown that this up here is true. This proof can be found in the book Proofs Without Words 3, page 157, and it was discovered by the Viewpoints 2000 group. If you'd like to purchase this book, visit the link below this video that will take you to my Amazon store. If you have any questions related to this video, leave them in the comment section below and I'll get back to you as soon as I can. For more mathematics proofs, make sure you're subscribed to my channel and visit mathematics.proofs on Instagram. Thanks for watching this video and see you next time.